how do we control everything that it does? This is where another package comes in. And this package, we have actually two packages that can handle this. We have Mocktail and we have a Mockito. I prefer to use Mocktail because it doesn't have as much boilerplate as Mockito, right? Mockito, you have to actually define a template and some long stuff. You can look into that later on, but I used to use Mockito before I switched over to Mocktail because it was easier. I mean, Clean Architecture's got so much boilerplate already. I don't want to have to add my own more boilerplate to my code before it works. So this is what the three questions we have to answer, right? So now let's go ahead and see, what does the class depend on? The class depends on the authentication repository, right? So let's go ahead and create. So now we know, what does the class depend on? Answer: authentication repository. How can we create a fake version of this authentication repository? Answer: use Mocktail. Boom. So now let's go ahead and install Mocktail. But when we're installing it, we want to install it as a developer dependency. Alright, not an actual dependency, because we're only going to be using it in, for example, our tests and so forth. We're not going to be using it in the actual, you know what. So let's go ahead and do that. Put pub add dev dependency. You can type out --dev, or you can just do 1d and that's it, and you can say Mocktail. So you can see Mocktail has been added. So Mocktail, you can go online and read its documentation, but essentially what it does is it creates a fake version of this. It hijacks all of its methods and then it lets us control them. Right? It exposes APIs to us that lets us control them. Right? So let's go ahead and do that. This is where we answered this question: how do we control them? Right? Using the Mocktail APIs. So let's start with our test. Right, so now we know what our class depends on, right? The second thing is, how can we create a fake version of the dependency? We use Mocktail, right? So let's go ahead and do that. In order to do that, we start by creating a fake version of the class. So we can call that fake auth repository, fake auth repo, but more conventionally we say mock instead of fake, right? So mock auth repo. I'm gonna just write auth repo because I don't want to type out that long stuff, but you can do that for, I don't know, better practice. Good practice is best practices or whatever. Always type out your class names in full. I think everyone would understand what auth repo is. Just for a test. Class mock auth repo extends, so this will extend mock. Right, mock is from the Mocktail package. This is basically saying this class will be a mock version of what? It will implement, what is it a mock version of? The authentication repository. Alright, so this is what our class is mocking. So this class is going to be a mock version of this authentication repository. Right, so now we've mocked it. We've created a fake version of the dependency, which is the authentication repository. Right. Next thing we want to do is void main start. So the entry point for all of your tests will be the void main. When you hit this, then your test will run. Right, but we don't have any tests yet, so I think that's not gonna work. So see, yeah, that's taking too much time really. There's no test. I'm just gonna stop that. Yeah, no tests were found. Agree. So now we start, right? How do we control what our dependencies do? Right, so we will answer that question later when we need to control what our dependencies do. So let's first of all start by writing our test. In order to write a test, you can use the test from the Flutter test package, which is also automatically added in every Flutter project by Flutter themselves. So you can run test, right? And it needs a description. So the convention for the descriptions are usually this test should, or this unit should, it should do what? It should in our case we want that it should, and what are we testing? We're testing create user. So it should call the let's see, repository dot create user method, right? I'm putting this in square brackets, it's just something I like to do when I'm talking about class, right? So because I'm talking about the auth repository, we can say auth repository, auth repo. I don't want this to be too long, so auth repo dot create user. We want to make sure that it always calls the auth repo dot create user, right? And we can add an async because we have to await a function, a future function, right? So now we want to make sure that it should always call the authentication repository dot create user. How do we do that? Right, so when we're testing, we follow 3 simple steps. We have the arrange, that is the first step. We act, and finally we assert. No, stop. So we arrange, we act, and then we assert, right? So what does arrangement mean? Right, so it's AAA, right? So arrangement means that we're putting together everything we need for our function to work, right? So what function are we testing? In this case, we're going to be testing the use case. So we're testing the create user use case. So we want that use case, and we want to call .call. So each use case has .call inside of it, but because it's a call, we can just invoke it directly, right? So we just want, whenever we're calling that, does it need any information from us? Yes, it does. What does it need from us? It needs a create user params, right? So we can go ahead and add a create user params and instantiate it and whatever, right? But then where's our use case, right? So first of all, we need to get code of our use case. So let's go ahead and save that here. So we start with late create user is our use case, right? And we can, now it's late, right? Late means we're promising Darts that before we use it over here, we must have instantiated it. How do we instantiate stuff in tests, right? We can't just do use case is equal to something, right? Because if we do that, then we only have one instance of the use case living throughout this. So if we actually used that use case in here, right, and then maybe change its value somewhere along the line, then the subsequent tests, the tests that follow, will also be using that same modified instance of the use case. But we want a case where for each test, if we had 3 tests in here, for each of them, we want a new use case to be created. So we can do that in something called a setup, right? The setup is also from the Flutter tests library, Flutter test package rather. So in the setup, it simply means do this every time that we start a new test. You can read it here. So it registers a function to be run before each test is run, right? So if we had three tests here, and then in the first test we actually changed something, maybe we arranged by saying that the use case dot whatever, maybe the use case dot, if it had a name, is equal to something else. Then when we do that, when we get into the next test, it will instantiate a new use case for us. All right, instantiate a new one. So that way we don't have to layer out or whatever, right? So we also have the setup all, right? So this will do this once for everyone, right? So this is it. Registers a function to be run once before all tests. So this will actually run once before anything else is done, right? And it will not be run again and again after each test, right? So after this test completes, it will still be the same use case instance that goes on to the next test. So in the So of all that, let's go ahead and continue with setup. We can make our use case to be equal to create user. We instantiate a new use case. Now, what's the problem? The use case wants a repository, right? So we've already mocked our repository. So why don't we go ahead and also create a repository? So the reason why I'm creating this repository separately and not just creating it in here is because when we're arranging, we're actually going to be using it, right? So late authentication repository repo or repository. Let me just follow those syntax, and then we can say repository is equal to the mock auth repo. We don't want to use the real instance of it. We want to use the mock version, and we can say that that will be our repository. Right. So now we get onto arrangement. Right. So if we had a function, right, we're trying to say call our function, right? Our function is the use case, right? When we call the use case, so when we call this, it will be an act. So we're acting on something, we're carrying out an action, which is invoking the use case. It needs some params, right? So what params does it need? It needs the create user params. So we can go ahead and create a create user params, and we can give created that name and avatar, right? I'm going to go ahead and make that a constant, right? But then this shouldn't be here. This should be in the arrange. So we arrange everything we need before we act, right? So we can say final params is equal to this. So this is what arrangements do. So we arrange whatever we need and we put it in here, right? Params. We can save that in there, right? But then in clean architecture test. So this is how normal testing a normal function would work, right? We arrange everything in there. But in clean architecture tests, remember the third question. We want to control what our dependencies do. We don't just want to act and give it these params. We actually want to control what it returns, right? Now, how does this use case return something? The use case does not just carry out its own function and return something. The use case actually depends on the repository. It calls the repository's function, and then it returns whatever the repository's function does. Now, who does the repository talk to? The repository does not talk to anyone. Right, so meaning that the last person in our chain of command is the repository. So the repository is the main dependency. Right, so we can then arrange what that repository will return. Right, so let me go over that again. We want to control or arrange what maybe the parameters that we use over here, or what this use case will return. This is what we want to control. We want to control what it returns at the end of the day. In order to control what it returns, we don't control this person, because this person isn't actually doing anything. Right, this person is actually listening to a higher up, someone up in the food chain, and then they're getting their command from them. So if we want to change something, we actually go to the higher up. We go up there to the presidential level and we talk to them. We say, listen, whenever this happens, you do this. So the use case is listening to the presidential. If we get to change the presidential, because sorry, I'm getting into politics. I'm no politician. But then if we get to change or control the president, then we essentially are controlling the constituents. Basically, we are in control of everything, right? So now that's what we're going to do. We're going to be evil cabals and control the president. Who's the president? The president is a repository. So we will say, sorry for not telling you about this. We will say when, right? So we're trying to. So it's basically like simple English, right? But the when is from the Mocktail library, Mocktail package, right? So we can say when what? When a function, so this is simply saying when we invoke, or when a higher order function calls, when someone calls what? When someone calls the repository, when someone calls the president, when the use case calls the president and says president create user, right? But for what? Create user, now we have to put in the arguments that it wants, right? So now that's the problem. how do we create these arguments, right? In mocking, when we have a class that we're mocking, right, in the when block, when you're creating these, you can use a keyword called any, right? And you can invoke that. Any simply means find a null value and use it for this, or sorry, find a generic value and use it for this. So first of all, checks the type. So the type for created that is a string. If it's a Dart data type, so for example, string, integer, and the rest of them, it will create a default value. So if a string, it might create a generic string called created at. It might just do this and put it in here, replace it in here. You can read the documentation for an argument matcher that matches any argument passed in. So it will simply just create and find out the type for it, and then create a string that will match that. All right. We're also going to do the same thing here, and we're also going to do the same thing here.